All right, hello there. Here's your this video is about section 1.3 in geometry. It's called measuring segments. So we're just going to talk about some basics about measuring segments. We are going to be introduced to a couple additional postulates. I know we talked about postulates just briefly last time, and some basic terms, but the main goal is the second one. So this would be your new goal to write down. Find and compare lengths of segments. Okay. Not overly challenging, but there are some specific things to make sure that you are precise when you're doing geometry with segments. Okay, so let's start off by, and you can follow through with this on your notes. It's very similar. Um, just the postulate that I don't have listed on here um, is called postulate 1.5. That's just a ruler postulate saying that every point on a line has a coordinate, but that's very basic. You should know that by now. So I'm skipping right into this term, distance. This is one of your vocab terms. I don't think this is one of the ones for the chapter, but the distance between 2 points A and B um, is the length from one point to another. And if you're looking at a number line, the way you say distance is very similar to how you would write the line PQ, but the distance, or sorry, we're going to do AB. Line AB would be with the line on the top, but the distance is just simply AB. So there's nothing over the top, no line, no segment, no nothing. So keep that in mind. When you see it with nothing on top, that signifies the distance for it. All right, 1 second here. All right. So example here, find PQ, QR, and PR on the number line. And we're just looking for the distance. Since there's no lines at the top, we're looking for the distance. So the distance between P and Q. I also would like to note, uh, you can find the distance by just doing very simply taking, and it should be green right now, A minus B, or points A minus B, whatever the coordinates for that would be. And the absolute value is always going to be the distance. It should be a positive distance. Now, if you have a ruler, though, you can just figure it out. This one is 1.5. And I would like a label, so 1.5 units in this case. QR there is 1, 2, 3, 4, 5 units. Oops, I spelled units wrong. And PR would be the total of both of those, so I think it's 6.5 units. Alright. Alright, so let's move on to the second postulate that I'm actually putting on here is postulate 1.6, and this is the segment addition postulate. Okay, and this is something you can use to prove things. A lot of postulates seem like common sense. That's why they're postulates. You don't have to prove them. They're just accepted as fact. So this postulate says if 3 points A, B, and C are collinear, remember that word collinear means on the same line. So A, B, and C are on the same line, and B is between A and C. So like over here, our example. Then you can fill in the blank here with segment AB. So we're looking to go with distances. AB plus BC is going to be equal to AC. All right, that's postulate 1.6. So we're going to use that a little bit here and solve some things. All right, so I told you we're doing a lot of algebra and geometry too, so you have to know your algebra. This is some basic stuff that we're going to add in. So we're going to use the segment addition postulate here with some algebra. It says GH equals 7y plus 3, so I'm just going to label that. That's what helps me, y plus 3. HI equals 3y minus 5. And GI, this whole thing, is equal to 9y plus 7. So the first part here, we need to find the value of y. Okay, so let's use that segment addition postulate. This plus this would add up to that whole thing. So let's just say 7y plus 3 plus 3y minus 5, technically like this, equals 9y plus 7. Since this is addition, we don't really need those parentheses using the associative property. Let's look for some common or some like terms here. Those are like, so I'm going to circle those. I'm going to underline the constants on this side. There's nothing over here that can be simplified. So we have 10y plus minus 2 or plus negative 2 equals 9y plus 7. Okay, and I'm simply going to subtract 9y from both sides and add 2 to both sides. I know a lot of this you can do in your head. I'm not sure where that green is coming from. Okay. That is weird. I have no clue where that green came from, and it won't go away. So anyway, try this again. So we'll go subtracting 9y from both sides, and we're adding 2 to both sides. Like I said, you can do these in the same step if you like, but I don't want to see you doing these in your head. At least show the one step, or doing it all in one step, and you're left with just one, or just y over here, and 9 over here. Okay, I want to see that. Show me that you can do some work here. And it limits the mistakes then. So that's A. We know that y equals 9. Part B says to find all those segments then. So GH. We said GH equals 7. And we're going to plug in for y is 9 plus 3. HI is, or high, equals 3 times 9 plus minus 5. And then GI is going to be equal to that 9 times 9 plus 7. Okay, so GH equals 63 plus 3 would be 66. HI, 27 minus 5 is 22. And 81 plus 7 is 88. And that actually works out. 66 plus 22 is equal to, that is a 22, 88. Okay, so there's your work for this example. Hope that one helped. We're going to move on to the next term, congruent segments. Our two segments are congruent here. It says if and only if they have the same length or distance. We do the same thing. I am so sorry. This is being really weird. So length slash distance, hopefully you can read that. The symbol for congruence is very similar to an equal sign, but what the heck? Okay. But it is adding a little squiggly on top. So a squiggly on top of the equal sign. So here's a key thing, and you need to know what the difference between equals and congruent is. Congruent goes with if you're just saying the segment. So over here, segment AB is congruent to segment CD. We're not doing anything with the length of it, just saying that those segments are congruent if you have this symbol over the top. Now, if there's no symbol over the top, you're dealing with an actual number. So that's actually the length of it. Then you can say they're equal. So equal goes with actually putting a number to it. So having a value of something. Congruent goes with the actual label. So segments or angles we're going to do too. Segments. Labels. The more we do, the more you'll get that. It's hard to explain, but if they're actually just talking about the segment, they can be congruent. If you're just talking about the segment length, so this is AB without anything on top of it, would be the length. Then you can say they're equal. Okay, so Use the figure to determine whether each statement is true or false. Explain your reason. So we're just doing some segment addition here. Our P, is that congruent to segment SP? TP and SP. Or is it SR? Oh, it is SP. So these are the two we're looking for. They're 1, 2, 3, 4.5. 1, 2, 3, 4.5. So those are congruent. Second one. PQ, is that congruent to SR? PQ and SR, 1.5 and 2. Nope. Sorry, it's false. And the last one, TQ and QR. TQ, oh, it's supposed to be purple. TQ and QR. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. False. Not the same. Alright, very basic stuff, just talking about segment addition. Couple things in there to note, though, from this page. Knowing how to label distance with nothing on top of it, and knowing the difference between, in this segment addition postulate, and knowing the difference between equals and congruent. Okay, we're going to move on. We have a little bit left here. The next term is midpoint. Midpoint, the definition is there. We're going to fill in a blank here. Midpoint. A point M is the midpoint of a segment ST if and only if M is between S and T, and, so drawing the picture here, we have line S, T. So if it's between them, and if and only if this is M, so SM is equal to MT. Or if you wanted to use the congruent symbol, it would be segment SM is congruent to segment MT. Okay. So what do we know about MS and T from the above definition from the word between? Well, it has to be between those. What do we know about MS and T? M is between S and T, and M is the midpoint of S and T, or at segment ST. If you can think of anything else to answer that with, feel free. But we got an example here, and then we have one more term. Actually, I'm going to skip to that one term. What does the word bisect mean? It's kind of right here. It's bisect means a point, line, ray, segment, or plane is cutting something in half. Exactly in half. And it'd also be crossing at the midpoint. If it's cutting a line in half, it'd be crossing at that midpoint. So crossing at midpoint of a line. All right. So here's example 1. S is the midpoint of AB. AC is equal to 5x minus 6, and BC is equal to 2x. Find the value of x. So just a little picture. Pictures help. You're going to find that you need to draw pictures a lot in math, or in geometry especially. So AB, and this is the midpoint, so let's see. AC is 5x minus 6. 5x minus 6. BC is 2x, so BC here is 2x. Back. Find the value of x. Well, what do we know based on the definition of midpoint? We know that these two things have to be equal. So 5x minus 6 equals 2x. A little algebra here. I'm going to subtract 2x from both sides, and then add 6 to both sides. And I'm left with 3x equals 6. When you divide both sides by 3, you get x is equal to 2. All right. So with that, you can try to answer the closing question, and I think there's an error analysis problem on there. Do that on your own, and come ready to talk about and practice stuff with section 1.3 on measuring segments. Our next section will be section 1.4 on measuring angles. So we're going to be talking about angle measures and different types of angles. So until next time, we'll see you.